guys, we are back with a lesson on quadratics. I have a factoring review to cover today, and some of you are going to need more practice with this than others. If you're really good at factoring already, you can kind of fly through this. If not, watch the video, rewind, and I can offer you some extra practice if you're struggling with this. So keep that in mind. Today we're going to talk about factoring all these different things. And I'm just going to start by looking at the next slide. This is a flow chart. It says the first thing you should always do is look when you're supposed to factor and see if there's a common factor you can factor out. All right, so take out any common factor first. And let's see, can I move this? Maybe. Then it says if you have three terms, okay, that's called a trinomial. And we're going to factor by guess and check. We are not going to do slide and divide in this class. You really need to get good at guessing and checking and looking for patterns, okay? And then other patterns we're going to talk about are the difference of two squares, like x squared minus 25 factors x plus 5, x minus 5. It's joyous. But then we have sum and difference of cubes, and those get a little more complicated, but this is a pattern you're required to know for Precalc. And then we do have just a couple examples of factoring by grouping when there's four terms. All right. So once again, as you go through this today, look for when you have only two terms, a bunch of perfect squares or perfect cubes, okay? This is 2 times 2, 3 times 3, 4 times 4. A cube is 1 to the third power, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27. And these are less recognizable. You're not as used to looking for these. The first few are the ones that I would probably put on a test or quiz, so just get used to looking for those special numbers. All right, so we're going to start out. This is a binomial, only has two terms. So can we take something out that they have in common? They are both divisible by 2, and they both have an x. When I divide out a 2 and an x, there is still an x left because you have to be able to multiply it back together to become 2x squared. Back here, if I divide a 2 out, I would have a 6. If I divided the x out, there wouldn't need to be an x here, so that if I were to distribute that back through, I would get 12x. So this is our factored answer. And because there's no more squares, we don't need to factor anything further. All right, let me move this one over. I don't know if it's interfering with the camera thing up there or not, but sorry about the noise. All right, this is a trinomial, so we're doing this. We have three terms. They have nothing in common. So now we need to FOIL these backwards, or think about how this FOILed together. So n squared came from multiplying an n by an n. And 36, unfortunately, has a lot of factors. What am I missing here? 3 times 12, 4 times 9, 6 times 6. I think I got them all now. I don't know. But we need factors that'll make a 13. Now, to multiply to make a positive, they need to both be positive or both be negative. But they need to add up to a negative 13. Some teachers may have had you practice this in Algebra 1. So they need to multiply to make this, but add to make this. So let's see, I'm thinking these add up to 13. So what if we did a minus 4 and a minus 9? Negative 4n and negative 9n would make negative 13. And then the first times first is n squared, last times last is 36. It's that middle term that's a struggle to get sometimes. All right, so another quick one like that. To get an x squared, they had no common term, so we're just looking to factor with two binomials, x and x. Factors of 15, not too many, 1 and 15, 3 and 5. They need to add to 8 because they're both positive. So we just have a 3 and a 5. And then the check would be x times x is x squared. Inside and outside are 5x and 3x. And 5 times 3 is 15. You have to be good at distributing or foiling things together to be able to check if you've done your factoring correct. All right, binomial tells me I can't do this business. I can maybe take out a term though. I can take an r out. That will leave an r squared minus 36. This is one of those special ones because this is the difference of two squares. The sum of two perfect squares you cannot factor, but the difference you can, because what happens, if you take the square root of this is r, and to get a 36, you would take 6 times 6, because the square root of this is 6. But one is plus and one is minus, and what happens is you get a 6r and a negative 6r, and so if you foiled this together, these would drop out, and so you just get r squared minus 36. So this is a factor pattern called difference of squares. All right, this one is also two perfect squares. They do not have anything in common that we can take out. So we just factor the square root of this is 4r, and the square root of 9 is 3. Whoops, I forgot my 4. And then one gets a plus and one gets a minus so that we get no middle term. 4r times 4r is 16r squared. 3 times negative 3 is negative 9. We're good. All of these, first of all, I don't know how to factor something with a cubic with 3 terms, but if they have in common an x, then I'm down to an x squared minus 12x plus 32. But we are not finished because we always need to make sure that our factors don't go any further, and these do. Factors of 32. If you need to use a calculator to find these, go for it. I think that's it. What will make a 12? Now, if they're positive back here, they have to have the same sign. But if it's negative here, they're going to both be negative because they need to add up to make a negative. So the factors of 32 that add up to make negative 12 would be negative 4 and negative 8, or negative 8 and negative 4. The order that's in doesn't matter. You could certainly practice foiling that all back together to check your answer if you want. All right. This is trinomial again. 2 of them. What is different is that for the first time, this number, oh, I just lost my cursor. This number is not a 1. So to get a 7b squared, I have to multiply like 7b times 1b. Now the good news is there aren't any other factors of 7 besides 7 and 1, so we're in pretty good shape. But there are quite a few factors of 70. We could have 1 and 70. We could have 2 and 35. We could have 5 and 14. We could have 7 and 10. I don't know if I've got them all. But let's see if any of these work. What we have to be real careful on is we need this term when we add in the middle to become 39. And we have a 7 here. So it's not just something times itself or something. We have to multiply 7 by one of our terms. Somebody told me once that you should just start with the closest together, so 7 and 10. Now, if I put a 7 here and a 10 here, I would get a 70B on this outside and a 7B on the inside. That's not going to make 39. But my hint to you is going to be that if I did that, I could take a 7 out of this parenthesis. Was there a 7 that was common to everything up here? No, so I can't have a parenthesis that has a factor of 7 in it. Now, Miss Abruzzo always says, don't erase, just rewrite, because she says you'll start guessing and checking the same ones over and over if you erase. So cross it out. We could try switching the 7 and the 10. Okay, can always switch the order. Now when I do 7B times 7, I get 49, and I do 10 times B, I get 10. Well, 49B and 10B differ by 39B. So if we could make this work, let's see. If the 49 was positive, right there, and we made this 10B negative, we'd get 39B in the middle. But does it check at the back? Negative 10 times 7 is negative 70. All right, so I think we made it work. Sometimes it's going to take you a few tries. Now, my first thought was that I could take a 2 out of everything, because I can take a 2 out of this and a 2 out of this, but that isn't going to work because the 2 can't divide out of 23. So I'm going to have to stick with 2A and 1A, and it doesn't matter which you put in which parentheses. And unfortunately, 56 again has a lot of factors. 2 times 28, 4 times 14. 7 and 8 is the one I thought of first, but if you want to try to start in the middle here with 7 and 8, I'm not going to put the 8 here because then these would both be divisible by 2. And there's no common factor here, so there can't be a common factor in my parenthesis. So let's try 7 and 8 this way. Now, if I do that, I get 16A, because I have to multiply 2A times 8, and 7A. Now, 16 and 7 could make 23, maybe, if I added. If this is plus, both my signs need to be the same, because a 7 times 8 is 56, only if they're both positive or both negative. But if we want to add up to a negative, we're going to need 2 negatives. So right now I have negative 7A on the inside, and on the outside I have negative 16A. If we add those together, we do indeed get negative 23A. So I think we got it on the first try. All right. Yikes. This time we could have 9x and 1x, or we could have 3x and 3x. And 40 has a lot of factors too. I don't know. Let's try a 3x and 3x, because I feel like that's what some of you would want to try first. Now we could have 1 and 40. 2 goes in there 20 times. 3 doesn't go in. 4 goes in 10 times. 5 goes in 8 times. If we start with the 5 and 8, we could just try them here and here. This time, if we need a negative 40, one's going to have to be positive and one's going to have to be negative. The 5 and the 8. All right, so right now I'm looking at 15, and 3 times 8 is 24. 15 and 24, even if they were the same sign or opposite signs, if we were adding them, we'd get 39, not 37. Okay, so even though one is going to be negative and one positive, like if I made this negative and positive, I'd get negative here and a positive here. That's not helping. Remember, we're multiplying, not adding and subtracting until that last step. So we could stick with 3x and 3x, and we could try something different. I don't think switching the 8 and 5 are going to help because they're both multiplied by 3. So we could try 10 and 4. We'd get 12 and 30. 12 and 30 aren't going to make 37 either. Before you get too crazy here, I'm thinking we might want to try the 9 and 1. So if I were to try 9x and 1x, and then we can, again, figure out which of these you want to try. If we start with 5 and 8, here we'd have 72 and 5. That's not going to make 37. Oh, we got a tricky one here. 10 and 4, 2 and 10. I'm sorry, 2 and 20, 1 and 40. Let's see. If we had a 5 here and an 8 here, we'd have 45 and 8. Would that work if we had, this would be 45x, and we need a negative 37, so if we made that a negative 45x, and then we did a positive here, we'd have a positive 8x, and negative 45 plus 8 is negative 37. Okay, so again, what you're trying to do, get them to multiply to this factor, put those in the front, multiply to this factor, put those in the back. And then you got to do this little inside-outside loop-de-loops and add those together to see if you get that middle term. So we were finally successful, but this one was tricky. All right, let's see if we can do any better here. Aha, I see a shortcut. These are all divisible by at least 2, right? So if I take out a 2, I will have 6x squared plus 35x, which is no longer even, so it's not divisible, and 47? That's not right. 46. Is that right? 98 divided by 2. I don't know. I need help. I'm gonna make the world's worst video if I can't. 98 by 2 is 49. Whew. Okay. Well, good news. 49 only has factors of 1 and 49 or 7 and 7. Don't lose this 2 out here, by the way, guys. Because remember, it all has to FOIL back together at the end. So I'm liking the idea of trying 7 and 7. Now, to get a negative, we'd need 1 positive and 1 negative. But to get this 6x squared, I could try 6 and 1 or 3 and 2. Oh, I don't know. I think I'll try a 3 and 2. Seems like what you guys might do first. This would be negative 21x, and this would be positive 14x. Yeah, that is not going to give me 35. It gives me 35 if I add them, but they have to have opposite signs, so it's not going to work. Going to keep that 2. Maybe we should try 6 and 1, because I don't think switching 3 and 3 isn't going to help, or switching 7 and, oh, that was a 2. We could switch, no, it's not going to help. Yeah. Switching 2 and 3 isn't going to help because there's still a 7 and 7 that we're multiplying by. That was a 2, I don't know, that's messy. All right, let me try this. Let me try a 6x and a 1x and a 7 and a 7. Could be 49 and 1, but if I do this, I get 7 and 42. I think we might be in good shape, because 6x times x would be 6x squared. Outside here, I'd have a 42, which I'm thinking I need to be positive. And then a negative 7x in here. So 42 minus 7 is 35 positive when we do the middle terms. So 6x times x is 6x squared. The middle terms gave us 35x, and a negative times a positive is a negative 49. So it does FOIL back to this, and then we had that 2 out front. So my very messy slide, this is our correct answer. All right, those were tricky, but we have a new pattern that you should have all seen in Algebra 2, but it's been a while. This is cubes. When you have, again, two terms, and it is the sum or difference of two numbers that have a cubed root. They follow one of these patterns. So x cubed is just x to the third power. 8 is 2 times 2 times 2. So this is the difference of two perfect cubes. And so we're doing this one. It's the difference. And it says what you do is you take a cube root of each and put that in a parenthesis. So the cubed root of x cubed is x, and the cubed root of 8 is 2. And it says if you had a minus here, this first parenthesis gets a minus. All right, now this is really kind of complicated how this all came about and why it works. But let me tell you this. To get an 8 at the back, you'd have to do 2 times 4. And it would have to be a positive 4. To do x cubed at the front, it would be x times x squared. The middle term is the one that's confusing, because the middle term in this parenthesis has to disappear so that there's nothing left in here. There's no x's or x squareds. To make that happen, what you need to do is take the a here, which was x, the first term here, and the term here, the ones that were cube rooted, put here, and multiply them together. So we get a 2x. Now you don't worry about the sign, because in order for this to cancel out and disappear, the sign has to change from what it was in that first parenthesis. So right now, if I FOIL this together, x times x squared is x cubed. If I take x times 2x, I get a 2x squared. If I take x times 4, then I go back and I do negative 2 times x squared, negative 2 times 2x, negative 2 times 4. Do you notice what happens to these like terms? They all drop out and we end up with x cubed minus 8. All right, before I go any further, this is the pattern that you will need to use for cubes. But I have a hint. The signs get confusing. If it's plus here, it stays plus here, and the back one is always positive. If it's minus to start with, it stays minus, but then it changes to plus. If it's plus, it stays plus, and then it changes to minus. So the phrase my students taught me is SOAP. This refers to the signs, okay? The signs in whatever this cubic is, you will take the cubed root of each, and then you keep the same sign here. That's what the S stands for. Keep the same sign, and then in the second parenthesis, it's you square the first one, you square the last one, and in the middle you do one of each. But the O stands for the opposite sign. The next parenthesis here is opposite sign, so it would change to plus. And the AP at the end for SOAP, it stands for always positive. So whatever you started with here, the sign stays the same, then it switches to the opposite of that sign, and the last sign is always positive. All right, so let's practice a couple more cubics. The cube 27 is a perfect cube. It is 3 times 3 times 3, so the cubed root is 3u. And 64 is 4 times 4 times 4, or 4 cubed. So we take one of each out and make it its own little parenthesis. Now we got to be careful though, because back here, remember this has to multiply by something to make 27. The pattern says, and I just moved the pattern off the top. The pattern says you take what you did here, A, and you square it. Be real careful, guys. 3u times 3u is 9u squared. because remember 9 times 3 has to give us 27. And then back here, 4 times what is 64? Well, it says you take the last term, the 4, and you square it, and you get a 16. And that one is always positive. But in the middle of here, you need a little magic. You need one of these times one of these, which would be a 3u times 4, or a 12u. And then the sign has to change, so from plus to minus. Now, somebody's looking at this thinking this should factor further. But it will never factor further, okay? When you have perfect cubes, this will not factor. Will not factor further. Unless there was something you forgot to take out at the beginning, it will not factor further. Somebody's going to look and go, well, 9u should be 3u and 3u, and 16 should be 4 and 4. But look what happens. If I do that with a plus and a minus, I would need 2 minuses. This would be negative 12u, and this would be negative 12u, which would be a negative 24u, not a 12u. See, it does not factor. I was just trying to prove to you that it doesn't factor. All right. I don't want to leave that in the notes because it'll confuse somebody. All right. Ooh, we got a trick here. I think we can take a 2 out of those at least. That'll be 125x cubed minus 54 divided by 2 is 27. Now these are numbers that are perfect cubes. This is 5 cubed. And this is 3 cubed. Okay? So I had to keep my 2 out front. Take the cubed root of this, and I get a 5 and an x. I take the cubed root of 27, which is 3. I keep the sign, which is minus. And the second parenthesis is the one that kills people. All right, troubles students, I should say. You take this one and you square it because I need to make it 125 when I multiply it back together, okay? So 5x times 5x is 25x squared, and 5 times 25 would get that 125. Back here, I'm supposed to square that one. 3 times 3 is 9, and 9 times 3 positive times this negative would be negative 27. Now remember the weirdness about the signs, if this is minus, it will switch to plus in this parenthesis, and the middle term is this times this, the cubed root times the cubed root. So 5x times 3 is 15x, and that will not factor further. All right, 2 real quick. Factor 4 terms. It says when you have 4 terms, you can group. So what you do is you look at maybe the first 2 and you say, what can I pull out of those 2? A 5p squared. That leaves me a p plus, let's see if I divide that by 5, I get 8. I took out both p squared, so I just have that. Now the goal of factor by grouping is that we need the same parenthesis back here. So I need to wind up with a p plus 8. Well, lucky for us, if I take a 2 out of both of those, I get a p plus 8. And then the trick is, you have all this, so you can take this p plus 8 out of each one of those, and the leftovers would be a 5p squared plus 2. And that's how that will factor. So on this one, I can take out of the first 2 a 5x squared. That'll leave a 3x plus 2. Now I need this next parenthesis to be a 3x plus 2. Well, both of these are negative, so if I just take out a negative 1, then I would be good. So now I can take the parenthesis out, the 3x plus 2. I write that down, took that out, and the leftovers are a 5x squared minus 1. Now, sometimes these will factor further, and this one kind of looks like it does, but a 5 is not a perfect square, so you can't factor that one further. All right, so that's it for factoring review. If you have an assignment to do tomorrow that includes factoring review, but if you need extra practice, I'm going to put a PDF on there that you could print or look at and do some more practice, and I'll make sure it has a key as well.